Hi everyone. Sorry I'm late. I have the directional capabilities of a One Piece character, so I got lost many times on my way here. Well, that's okay. We're gonna get right into it. My name is Jemima Abu, and I'm here to talk to you about functional programming. Yes, once my slides click. Brilliant, it worked. So I am a front-end developer, self-taught, and a school-taught systems engineer from Lagos, Nigeria, so I'm a long way from home. But I'm actually working in Lithuania, so it was like a shorter flight. And yeah, you can find me online anywhere at Jemima Abu. So that's Twitter, LinkedIn, Medium, GitHub. It's fun. So let's get into it. What is functional programming? Basically, in the world of programming, we have things called paradigms. Paradigms are the way code is written, pretty much. So functional programming is a concept that was invented in like 1954. And in this concept, they basically say you write code using pure functions. And I'll elaborate on what pure functions mean, but first we have to look into what the basics of functional programming are. So basic functional programming, you have pure functions. How pure functions work, think of it as like a mathematical equation. In math, 2 plus 2 is always 4, right? It doesn't matter if it's on a mountain or in the middle of the Marianas Trench, 2 plus 2 is always 4. And that's pretty much the concept of a pure function. With a pure function, whatever input you give in should always return the same output. So if you have a function and you return one input, it should always give you the same output no matter how many times that function is called. Or, like a predictable output. So you can take it as functional programming is predictable programming. I would say that's the basis. It also works with the values of, with immutable values. What that means is that don't change your values, pretty much. Immutable values are values that aren't modified in ways that you don't expect. So how that works is that every time you, let's say, modify a value, it doesn't exactly change that value, it just creates a new instance of a changed value. And then you have higher order functions. Higher order functions are basically functions that take in other functions as arguments. This is very common with JavaScript and in other languages too, like Python and stuff, when you have like your map functions or your reduce functions, it's passing a function to a function as a parameter. I said function so many times, it doesn't sound like a real word anymore, but that's okay. And then finally, we have minimal side effects. The principle of functional programming, like we said, it's predictable programming. So that means you want to minimize unpredictability, pretty much. And then functional languages. I'm going to skip through this part because I have the JavaScript part and that's where my main focus is. But functional languages, these are languages that were created to be functional by default. So that means you write them using all the principles of functional languages. You have languages like Haskell. Haskell was created to be purely functional. You have Clojure and Erlang and Lisp. Lisp was actually the first functional language that was invented. So that's fun for it. And then you have Scala. And then we have JavaScript. I think of JavaScript as like this giant monster because it just kind of does anything and everything. You can write JavaScript functionally, you can write it with object-oriented programming, or you can write it as procedural. So JavaScript was not intended to be written any one way, but it can be written in... Basically, JavaScript is more of it's prototype-based, So you can write it however you want. But in this talk, we're going to be looking at how to write JavaScript in the functional way. Oh, no, we have to look at the benefits first. I forgot I had these slides. So why functional programming? Number one, like we said, it's a predictable language, so it's less prone to error. When you have a database or you have a website or whatever, and it's collecting data, you want to minimize how often you get results you're not expecting. 500 errors and stuff like that. And your code is more readable. Functional languages are written in a way that has predictable code. So if you have a function that says get username, you expect that function to return the username. It'd be really weird if you return the password, because now it's what do you call it, get username. And then it's easier to test and debug. Because all your functions are predictable, it's easier to know where an error is coming from. So if I'm trying to call data from a database and I'm getting the wrong value for, let's say, somebody's age, I'm probably just going to go to my function that's called get user age. And I know where my error is coming from. And finally, it allows for easy reusability of functions and variables. We see this a lot when you're writing React code. When you have all your components already predefined, it's easier to just impute them into other components instead of having to write new things all over again. And finally, no more this. When I first started learning JavaScript, when I first started learning React, this was the bane of my existence because you'd have to write class components. And I didn't get why we had this, but then if you want to use this in a different class, this then becomes that, because this would not work if it's in another function. Like, it baffled me to no end. So yes, that is my favorite benefit of functional programming. We don't have to deal with this anymore. And we also have arrow functions for the win. This is no longer a problem in arrow functions because this in an arrow function always refers to the function you're calling it in. So what that means is if I have nested functions, if I call this in function A, it's referring to function A, but if I call this in function B, this refers to function B. So easy, simple, and great. Let's get to the fun part, functional programming in JavaScript. So we're going to look at each of the basic concepts of functional programming and see how we can apply them to the JavaScript code that we are writing. So JavaScript in itself, like I said earlier, it does have its functional part. So if we look at React, originally when React was written using class components, we would have to define it using the concept of object-oriented programming. So we had to use this a lot. You know, you had your this.state and you had this.setState, and if you wanted to refer to a variable, you'd also have to use this, and they would all have to be defined in their constructors, with their supers and stuff, but then React hooks came out, and React hooks are based on the principle of functional programming, meaning we no longer have to use this to refer to any variable. We can just use our hook, and we can define our React component as a function. So that's why you end up having things like const, my component extends React.components, and then you can also define your state variables just using const, and you don't have to refer to them using this because everything is already inside that functional component. Yes, that makes sense. I'm moving on. So basically, the concept of functional programming in JavaScript is that a web app is just a bunch of functions stacked on top of each other wearing a trench coat. So this is what I like to imagine it looks like. You just have your components, and you combine all of those to build your main web application. So yes, this is the basic structure of most React web applications. You have your main application, and then you just call all your child components into it. This is the concept of functional programming. You want to create tiny reusable functions that you can then combine to build. It's like a design system, basically. You create tiny reusable functions that are easily defined, and then you combine them to build more complex functions, and so on and so forth until you have your whole large application. And it's great. So yes, let's look at writing pure functions in JavaScript. So before we look at pure functions, we have to understand what impure functions are. So let's take a look at this function. It's a simple piece of code. We have our variable a, and we're setting it 5. We define our function add, and basically what add does is that it adds b to a. So if I call add 6, it returns 11. This is an impure function. The reason this is impure is because number one, it depends on a global variable. You do not want your functions to depend on anything outside of the scope in which you are calling that function, because what happens is if that variable is changed, it affects your function in a way you didn't intend for it. So here you can see we've defined variable a as 5, and we've defined our function add. But now let's say this was a database, actually. Let's not even think of it as this simple function. Let's say somewhere else you were doing something with variable a that happened to change it. But now, in this, it's suddenly affecting your add function in a way that you did not intend. This is one of those unintended side effects we're talking about. So what happens here is that a is modified, and that affects your function add. And then it's returning a different value for the same inputs, which is not the predictable output we're looking for. So yeah, avoid doing that. A pure function would be ensuring that your function is only determined by the parameters that you define in it. What this means is that we're defining all our functions in the scope of the function we're using. We have our add function, and we have our parameters a and b, and we're returning a plus b. This function will always give you the same values as long as you're passing the same variables all the time. So this is how pure functions work. You want to make sure that it's only dependent on the input you're passing in, and it always returns the output you're expecting. Yeah, this is like the easiest way to define it, really. So yeah, it works on input only, and it returns same value for same input. So this is a fun little one. So this, based on the previous definition, we have a random number function. It's depending only on the number parameter, and it's only returning a value we're expecting. Would you say this function is a pure function or not? Let me just say, like, show of hands, it's a pure function. Oh, thank you. Show of hands, it's an impure function. Damn, okay, y'all smart. Love that for you. Basically, the reason this function is an impure function is because in itself, it does not return the same value for the same input. If I pass in the same value, 4 times, it gives me a different input 4 times. That in itself is not a pure function. So it's catches like this because, I mean, it's defined as a pure function, but then it doesn't fulfill all the requirements of a pure function. So, I mean, to be fair, you're hardly ever going to call random numbers in your database. Oh, you do, actually, when you have to store user inputs. That's beside the point. The point is, it's not a pure function in itself. But then, would you say this function is a pure function? We have our maximum array function, and we're passing an array, and it returns a value that it applies to that array. Would you say this is a pure function? Damn, y'all are nervous now. Is it an impure function? I see we're very on the fence. Yeah, no, this one is a pure function because, by definition, it does return the same value for the same input that's passed into it. So this is also an example of using higher order functions, but we'll get to that later. I will not spoil the surprise for now. And then we have immutable values. Immutable values are, I feel like people get really angry with JavaScript just because JavaScript allows you change values all the time. It's like you define a variable as const, but then later in the code you change it and they're like, if it's const, why are you changing it? But that's just JavaScript, and JavaScript is a beautiful language that lets you do whatever you want, which is why I like it. So we have our function here. We've defined our, wait, I have a pointer that I want to use. Yeah, I love that. So we've defined our array here, and we have a function reverse array. Basically, what this function does is that it reverses an array. See, that's the fun with functional programming. Very easy to define component names. And then we have our new array function here. So what we're trying to do is that we're trying to set new array as the reversed array. But then what ends up happening is that this function here reverses both arrays that we've just defined, which is weird, right? Because here, it has nothing to do with the global variable ARR, because what we're passing is the parameter array, which is completely different. But the catch is, because JavaScript is a beautiful language, it works the way it works. So if you pass in a variable, like an array or an object, to a function that carries out, let's say, mutation on that value, it's going to affect the original array, regardless of whether you refer to the global array or not. So that's why in JavaScript we end up using, no, frick, I keep on forgetting I have these things. Yeah, original array is mutated. Great, we have a helpful little arrow there. That's why in JavaScript we have things called spread operators. What happens to a spread operator is that it creates a new instance of that variable that we've defined. In JavaScript, when you're working with arrays or objects, you want to always work with new instances, and you do not want to modify the the original array. And I'm going to use database example again. And the reason I keep using this is because we were just working on a like this login screen that has to be taking a lot of user data for like this dashboard, and you would not believe the hell that it is when people start mutating user values, because you're trying to, let's say you're trying to get the first letter of everyone's name because you want to sort the arrays alphabetically. Well, now because somebody forgot to create a new instance, you end up having an array that is just the first letter. You end up having a database that is just the first letter of people's names. It's not pretty, so we try to avoid doing that. So that's why in JavaScript, we always create new instances of things. So with this one, we use a spread operator to create a new instance, and it's that spread operator that we then reverse. And what happens is that our original array maintains its original values, and the new array has the intended effects. So that's kind of how the principle of immutable values works. You want to always avoid mutating the original values and only create new instances, which you then pass to the variable that you want. Yeah, that's an easy definition. Array is not mutated, great. And then we come to the principle of higher order functions. So higher order functions are basically passing functions into other functions. Let's take a look at how that one works. So here we have another fun little function. It's called the, we have our defined variable, and we have a function double. What we want to do with this function is that we want to multiply every item in that array. So you could create your for loop, and then for each item in the array, just set the array value times 2. This is bad, because what you're doing here is that you're literally reassigning every value in that array. So what you're going to end up with is, once again, mutated values. And that brings us to the concept of higher order functions. When you're passing a function to another function, it creates its own new instance by default. How that works is, here, instead of using that for loop that we had previously, we replace our for loop with a map. And then we pass in this function x, X is just the item in the array, which then returns X times 2. The way the map works is that it only affects the new instance of the array that you're creating. It does not mutate your original value. So the same thing with maps, with for eaches, with reduces. You always want to avoid mutating original values and only create new instances. So yeah, things like map, higher order functions basically used a lot in functional programming to avoid having, what's the word I'm looking for? To avoid having mutated values. And that's it. It's beautiful. Function that takes a function as a parameter, does not change original array value. And then minimizing side effects. Like we mentioned earlier, for the third time, functional programming is a predictable language. So when you're writing it, you want to avoid having side effects that you were not expecting. So let's take a look at what a side effect would be. Here, we have our function add. And then we're returning a plus b, but then we're also console.logging hi NDC Oslo. A console.log is a side effect because what it's doing is that it's returning something other than a value. With your functional, with your functions, you only want to return values. You don't want to carry out any other feature that your function is not intended to do, because that's how you end up having like spaghetti code and things changing things they're not meant to be changing. We also have our array, which says hi NDC Oslo, and then we return a printed array. Problem with this one, once again, is that it's mutating a global variable. Join does mutate global variables, and this is something you're trying to avoid. You want to avoid mutating global variables just because, it's bad. Was that where I was going with this? Yeah, okay, cool. Applications of functional programming in JavaScript. That went so fast. We have React functional components, which we spoke about earlier. In React, when you end up using hooks and stuff, you do not have to define your components as classes. You no longer have to have constructors or supers. You can just export the default function, and then you can call all your variables the same way you'd expect. React hooks still work with the basis of functional programming in that you have a main function, and it returns what you expect it to return. The catch is, a lot of times in components, we end up defining a lot of other stuff inside here. That's all the handler methods for our components, but we'll talk about that later in what we call necessary side effects. And then we also have React reducers. If you've worked with state management properties in React, you end up using reducers a lot to just handle global states. React reducers also work with the principle of functional programming, in that for every case you define, you expect it to return a new value. Another thing that's very important with React reducers is that you do not ever modify global states. And you realize how important the principle of functional programming is when you start working with global states, because if one if one component is modifying states in a way that it's not supposed to do, it's affecting the rest of your code, meaning that, well, you can imagine the catastrophe that would be if one thing was changing state and another thing was calling it, and then you just had it'd be chaos. So yes, React reducers work with the principle of functional programming in that they always create new instances of states, and whatever value they modify is just returned as a new state instance and not modifying the original one. And then we also have functional libraries for JavaScript. So these are libraries that allow you write functional code in JavaScript. It kind of holds you to a higher standard, because there are people that prefer JavaScript to be harder than it is. I'm not one of them, but if that's what you're into, we do have functional libraries that ensure that you write JavaScript in a way that is stricter, I would say. So all of these ones, I will be giving out the slides later, so if you're interested in them, you could always click the links. And then handling necessary side effects. Like we said, with most things in life, it never goes the ideal way. In JavaScript, when you're working with web applications or whatever, side effects are necessary. It's impossible to avoid console.logging things. It's possible for your functions to only return the things that you intend. So we're going to take a look at how we can handle a few of these necessary side effects using JavaScript. The necessary side effect would be an asynchronous request. Technically, an asynchronous request is not a pure function, because it's a function that it carries out a value and then you have to wait for that thing to be returned, meaning other things are happening while that thing is happening. It's not predictable because you might end up getting an error you did not intend to get, or it might end up just doing things that asynchronous functions do, where they just return unfulfilled promises and stuff like that. We also have logging. That's handling things like logging errors or logging data. Console.log is a necessary side effect a lot of times in JavaScript if you want to catch errors in a certain part of the code, basically, or if you want to test. And routing. If you use React Router and you have to call the link in a separate way than the intended way. I'm trying to think of I had like a use case for it from work, but it went away. But routing is also a necessary side effect. And then periodic updates. This is just things like recently we had to build this countdown timer for Black Friday because they wanted to count down to Black Friday. Doing things like set timer, where you're constantly running a function where it's not returning the same value all the time, will technically not be defined as a pure function, but it's also a necessary side effect because sometimes you just need to constantly update your page periodically. It is that. So one way of handling necessary side effects is to extract them. If you have like an API folder where you kind of store all your calls that you need to make to the different APIs and stuff, you can put them in a separate folder and define them as their own function. So technically what that function would do would be to return its own response. And then you could import that into somewhere else and then return that function into somewhere else. So it's kind of like extracting non-functional code to make it work as functional, if that makes sense. Anyway, basically, you end up using this a lot of times in real-life scenarios just because the more code you write for a application, the more bulky your system gets and why you need to extract things more into folders and stuff. And then functional using middleware functions. If you end up working with React reducers, like we said, reducers do not take any side effects. So you can't do anything else to reducer apart from modifying the state you're passing into it. But then what happens if you need to validate a user entry from state? So let's say you have your user login details, and that's the state value. So you have user name and you have password as your state values. But now, before you store those values, you need to validate them. For example, you need to make sure username only contains string. I need to make sure password fulfills the password requirements, where it has a capital letter and it has a symbol in it. React reducers would not allow you to do any of that because all of those things count as side effects. All React reducer cares about is updating state. That's where we include the principle of middleware functions, and there are libraries that allow you to do this by yourself. So how middleware functions work, basically, is that they take the store. The store is where your global state value is stored, and then they call a next function. That next function is where your side effects would be stored. So in my next function, I would decide what side effect I want to carry out on the state, basically, before it's passed. And then they pass that value to the action. So middlewares are basically just like, like a small little box where all the magic happens before the actual action is passed to the reducer. That's kind of how I like to think about it. Side effects, dispatch, modified action. Yeah. And that was a very quick, but yeah, that is all I have for you guys today. I feel in my head this thing took so much longer because it's like 70 slides, and I was like, yeah, that'll be well over 1 hour. I was wrong. So here we are. If you want the links to the slides, you can find them on my website, jemimaabu.com/talk/functional-programming. And also, if you want a list of further resources you can read up on, I found a few online. I really like this talk by Anjana Vakil. She's actually the reason I wanted to learn functional programming in JavaScript. So if you come across that, I would definitely recommend checking it out. There's also released some really great articles by Ali Spittle and Maximilian on functional programming and exploring the different types of programming paradigms, and then some with just related to JavaScript and functional programming. That's all. Quick talk. Love that for me. Thank you very much. I'll be taking some questions now, if anyone has any questions. If there are no questions, I will be referring to some of my previous questions from the last time I did this talk, because I always come prepared. So I think last time I did this talk, someone did ask, how practical is it to use functional programming in like the real life? Because the reason a lot of JavaScript developers in particular do not like using functional programming is because it's a good way of writing code, but it's also a longer way of writing code. Sometimes you don't want to have to define 3 different functions when you can just cram everything into one function. You know, you're on a deadline and things are taking a while. Just cram everything in one function. If it has a side effect, so be it. And what I like to say with that is that it is practical in a real life situation in the same way how important your code base looks to you is practical. Because while it may be faster to just write JavaScript in the JavaScript way, it gets unreadable at a point. If you are calling multiple instances of something, or if you just have like one giant file where all your code is just compiled, and then you have an error, and then you have to start console. Every single time I have to console.log 4 different values in one function because I'm not quite sure where my error is coming from. I'm like, curse you, object-oriented programming. With functional programming, you kind of avoid doing that. So that's what I would say. I would say it's like, it takes more time, and it is kind of annoying, but it's also kind of good because it has its benefits. So that would be the answer to that question I asked myself. Any other questions from somebody that's not me this time? Yes, thank you very much.
I was just wondering, you mentioned like functional libraries like Lambda and stuff.
Yeah.
Do you tend to use that in like front end with TypeScript? Because I've noticed it's the support for TypeScript is maybe not so great, and like in my company they tend to want us to kind of just use JavaScript or TypeScript without any, well, with minimizing libraries.
Oh, good question. Let me think about that. I do know that when we do use TypeScript, but we only use it on one project just because TypeScript is freaking annoying. It's good. It's great. You should always define your type strongly. You know, you want to ensure that you're getting data in the way you intend to get it. But yeah, no. With minimizing it using other libraries, I do not know actually, just because like I don't use...
Lambda.
Yeah, I don't use functional libraries myself. Yeah, like I said, I like JavaScript, you know, in the messy way it is. So, but if y'all are interested, that's why I have them for you guys, not for me. All right. Any other questions? Thank you.
So when you're using the middleware
Yeah.
before your Redux state, in the project I'm at now, there's these async functions.
Mhm.
And the way it's set up now, it's not returning a promise, so I sort of have to listen to when the state state. Do you have a good method to do that in a better way?
Yeah, so actually you know what? I have why did I do that? I have a talk on middleware stuff, and I did include a function there just on using, so what we use epics in combination with Redux, and we've worked with Saga as well. So basically how it works is that epics uses observables. So it kind of detects itself when the promise is returned, and then it carries out the updating states. So let me see if I can find that real quick for you. How do I escape? Look at that, 2 talks for the price of 1. Aren't you all lucky? Yeah, my screen does not want me to leave. How do I? Wait, hold on. Who knows the key for like exiting full screen with Max? Is it F11? Is it? No? I'm pressing exit, yes. Exit. I am calm.
Shift command up.
Shift command up. Yeah, that didn't work. I'm stuck on my screen. I will define it with my head. So, yeah, we use fx observables, and how the observables work basically is that you pass in a function. It's kind of like with promise.all. You kind of just passing a function to the observable, and it waits until all the promises have been resolved, and then it will return the value. So that's kind of, for me, that's the easiest way for detecting, for handling asynchronous promises. So case in point, I'm working on this project we're working on at work. We need to use the Google Time Zone API to return the time zone for a particular location that a user is passing. So what we do is that we get the location, and then we have to map that location with the time zone API. So mapping itself cannot be an asynchronous function because it defeats, like I said, mapping is kind of intended to be functional because it's a higher order function. So we cannot use an asynchronous function with maps. So what we end up doing is that we end up using a promise.all, and then passing that value into the map. So what we do is like you await your promise.all, and then you call your map function, and then you call your async function, which is the defined asynchronous function. You end up using like 4 await keywords in the one thing, but yeah, that is the catch with handling necessary side effects, So I would recommend observables or just trying to catch your promises, Catch those little promises. All right, I've gotten 2 questions, which is very good, but I'm willing to take more because I'm generous. Anybody else? I'm here for a while, so you guys, come on. It's just going to be awkward if I'm standing on stage. Actually, let me see how many minutes. Yeah, like a lot of minutes. Whoosh. Any other questions? I am willing to take questions outside of functional programming as well. You can ask me stuff about JavaScript, and I will do my best. No? No? Going once? Going twice?
I have a question. Yes.
Yes!
When I've used JavaScript, there's often been a lot of weird things that surprise me. Do you have any good resources for learning those weird things?
JavaScript. Yes, JavaScript is unpredictable in the best of ways. Kind of how sometimes things are false, but then sometimes they're true, but not all false things are equals to other false things, Like an empty array is not technically null, but it could be undefined, and then you're like null is not undefined. What does that even mean? Anyway, I too have a lot of problems with JavaScript. What would I recommend for understanding the weirdness that is JavaScript? I think, honestly, I just kind of accepted it, I was just like, sometimes things are just things like that. But that's a bad answer. Let me look something up for you. Have I come across any fun articles on understanding? Honestly, it's just a lot of Twitter threads of people complaining about how annoying JavaScript is. I literally cannot think of anything that's actually helpful. But if I do, I will include it in these slides, and you will have access to it. How does that sound? Or you can find me after, and I'll look something up on my phone right now. I'll let you know. Yeah.
I think the one next to me recommending a book.
Yeah.
You don't know GS.
I know. I'm joking. I know the title of the book, but what an offensive name, huh? You don't know JavaScript. That is a fun one. Yeah, I went like 4 pages into that one, and I was like, "You're right. I don't know JS," so I closed it. But if you want to read it, you should. I also read JavaScript for Dummies because I have a thing for books that insult me, apparently. So maybe you could check that out as well. All right, I've gotten 3 questions. If there are no more, I will pack up. That's a lie. I'm staying here till I get more. Yeah.
Do you tend to use like any functional patterns a lot? And what are the benefits of the ones you use? Like which ones do you use and what are the benefits of those?
Yeah, so with functional patterns, at work, we work with atomic design, and we try to always stick with like at least using pure functions. So how that works is that we break our components into atoms. So what we would have is that we would have a button component. Button components will always return just the button. So in that button component, you can define all the variants of a button that you would like, So you could have primary button, secondary button, you could pass in any parameter, and then it would always return what you expect. And then from atoms, we go to organisms. Organisms combine atoms. So let's say I have a button atom and I have a label atom, and I have an input atom. In an organism, I could have an input field organism, which would then take an input and a label. And then from an organism, you go onto a molecule where you end up combining organisms. I hate when I say too many words, but you understand what I mean, I hope. And you go from molecules finally to templates, I want to say. So basically, how we work is that we build on tiny functions, and we use those tiny functions to build larger functions. Because you're working with tiny functions, you always want to make sure that all your tiny functions are predictable, so that when you use them in your larger functions, it avoids having side effects you don't intend. So yeah, that kind of pattern, we tend to use pure functions more. The things like minimizing side effects, like we've said, side effects are necessary in JavaScript, so we just try to handle them as best, but yeah, we're not purely functional in that aspect. So that is that. I got 4 questions, I'm on a roll. Let's make it an even 5, huh? I'm greedy, yes. I know I said I'd stop at 2, but I'm hoping for 5 now. I have time. We have lots of time. Yeah.
I'm not used to JavaScript.
Sorry.
In Haskell, you pass errors through functions. Is there a way to do that in JavaScript?
Oh yeah, in JavaScript we just use catches. So how that works is if you have your, let's say you're fetching value from a database, you have your try and your catch functions. So with try, you just, if the function is okay, then pass the response. If it's wrong, catch that error and then return that error to something else. So with our projects, we use like toasts, like those tiny little notifications that pop up. So if we catch any errors, then we just pass them to the toast value, and then my computer restarted. Weird. So we pass the error to the toast value, and then that's kind of how we catch it. Is that similar to what y'all do in Haskell? How do you do it in Haskell? I don't know what that is. What's a monad?
That's difficult to explain. To say the least. You can do a lot with monads.
Is that monads, like MONAD? You learn something new every day. All right, great. I've not used Haskell. I feel like clearly I don't look like the kind of person that would write Haskell. My brain does not work that way. So, but thank you. That was a good question. All right, I got 5 questions, and my laptop shut itself down, so even it is tired of me, so I'm just going to close this now. If you guys do have any other questions, like I said, you could ask me on my website, jemimaabu.com, or on Twitter, @jemimaabu, and, I'd love to chat. So thank you so much for listening, even though I went off topic so many times, just so many times. But thank you guys very much, and enjoy the rest of the conference.